Hello everyone. On this video we will be looking at how to convert fractions to decimals. Okay, so to do that, just a quick reminder that you can rewrite division problems. We have the numerator divided by the denominator. You can rewrite that as the numerator divided by the denominator with the quotient being your answer. Also, you can add as many decimal digit zeros as you like. It's the exact same value. So 3, you can make that 3.0, 3.00, 3.000, and you can keep adding decimal digit zeros. It doesn't matter how many you want to add. Okay, so our next rule for converting fractions to decimals, you have to remember the following. When converting a fraction to a decimal, you want to keep adding decimal digit zeros until one of these three things happen. Your remainder is equal to 0, then that's when you know you have a terminating decimal. Your remainder appears to repeat infinitely, so you get the same values in your quotient repeating over and over and over again. And you have reached the desired number of decimal digits in your quotient. So if you want to round to the nearest thousandth, you want to make sure you at least have a quotient with a 10,000th place so you can round it. Okay, so you always want to go up one decimal digit past your whatever value you're rounding to. Okay, so if you are still writing this, of course, feel free to press pause, but we're going to go ahead and start on a few examples. Okay, so we're going to convert 5/8 and 4/5 to a decimal. All right, so starting with 5/8. Okay, so we know that 5 divided by 8, of course, we're just going to rewrite that as 5 divided by 8. Okay, so instead of 5, we're going to make it 5.0. Just for now. We can always add more zeros after. And remember, your decimal, when you're dividing, your decimal just goes right up above the division bracket. Okay, so 8 goes into 5. It doesn't, so we put a 0 there. 8 goes into 50 6 times. 8 times 6 is 48. We go ahead and subtract. 50 minus 48 is 2. We add another 0 and bring that down. And that gives us 20. 8 goes into 20 2 times. 8 times 2 is 16. 20 minus 16 is 4. So we go ahead and add another 0 and bring that down. 8 goes into 40 5 times. 8 times 5 is 40. And we have a remainder of 0, so we can stop adding our decimal digits. Or decimal digit zeros. So we know 5/8 is equal to 0.625. Or 625 thousandths. All right, so that's how you convert a fraction to a decimal. All right, so what I want you to do is go ahead and press pause and try this one on your own. All right, so assuming you've already pressed pause and started on and finished this one, let's go ahead and verify your answer. Okay, so we know that 4 divided by 5 becomes 4 divided by 5. And instead of 4, we'll make this 4.0. And remember, your decimal just goes straight up. Okay, so 5 goes into 4. Well, it doesn't. 5 goes into 40 8 times. 5 times 8 is 40. We subtract. 40 minus 40 is 0. So there you are actually done because your remainder is 0. So we know that 4/5 is equal to 0.8. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and do a few more examples. Okay, so we have 7/12 and 2/3. Okay, so the 2/3, we're just going to round to the nearest hundredth. All right, so I want you to go ahead and try both of these on your own. Okay, go ahead and press pause. All right, so I'm assuming you've pressed pause and worked these out. So let's go ahead and verify your answers. Okay, so 7 divided by 12 becomes 7 divided by 12. All right, and we go ahead and make that 7.0. Okay, and we move our decimal straight up. Okay, so 12 doesn't go into 7 at all, but 12 does go into 70 5 times. 12 times 5 is 60. Go ahead and subtract. 70 minus 60 is 10. So we go ahead and add another decimal digit 0 and bring that down. 12 goes into 100 8 times. 12 times 8 is 96. We go ahead and subtract. 100 minus 96 is 4. So we add another 0 and bring it down. So let me clean up that 4 a little bit. There we go. Okay, so 12 goes into 40 3 times. 12 times 3 is 36. 40 minus 36 is 4. Add another 0 and bring it down. 12 goes into 40 3 times. 12 times 3 is 36. 40 minus 36 is 4. We add another 0 and bring it down. And hopefully you're starting to see a pattern. 12 goes into 40 3 times. 12 times 3 is 36. And we see here, no matter how many zeros we add, at this point, we're always getting a remainder of 4. And it's just going to keep repeating and repeating over and over. And we'll constantly have just a bunch of 3s after this. Okay, so this is what you call a repeating decimal. Okay, so we know that since we don't have an exact value because our remainder is never equal to 0, we know that 7 divided by 12 is approximately equal to, so we put our little wavy equal sign. That means like approximately equal to 0.58333, and we can put as many 3s as we like. It'll keep going on forever. Or put 7 over 12 is approximately equal to 0.5833, and we can put a bar over that. Okay, because whenever you put a bar over it, that means that that value just keeps on repeating. So here the 3s, you can put 1 3 with a bar over it, or 2 3s with a bar over it, and it just lets you know that that 33 will keep repeating over and over and over again. All right, so let's go ahead and move on to our next example, which is 2/3. So once again, I'm assuming you've already finished it, so let's go ahead and verify. Okay, so 2 divided by 3, remember you're just going to rewrite that as 2 divided by 3. And that 2, we're going to make that 2.0. Okay, so 3 goes into, oh, remember our decimal point goes up. 3 goes into 2, it doesn't, so we put a 0 there. 3 goes into 20 6 times. 3 times 6 is 18. 20 minus 18 is 2. So we add another decimal digit 0. 3 goes into 26 times. 3 times 6 is 18. 20 minus 18 is 2. So we add another decimal digit 0. And hopefully you're starting to see the pattern. 3 goes into 26 times. 3 times 6 is 18. 20 minus 18 is 2. Now we can see here that we want to round to the nearest hundredth. So we have tenth, hundredth. So we need at least 1,000th spot. Okay, so we don't have to do any more, because if we're rounding to the nearest hundredth, we need at least 1,000th spot. Okay, so we see that 2/3 is equal to 0.66666, and it'll keep on going forever and ever and ever. Okay, since we're rounding to the nearest hundredth, 10th, hundredth, so that's our hundredth. We go ahead and circle the value next to it. Since that circled value is 5 through 9, that means our underlying value goes up 1. That means it's approximately equal to 0.67 when you round it 2 decimal places. All right. So if you're still writing, feel free to press pause. We're going to go ahead and do one more example. Okay, so we want to convert 3/11 to a decimal. Okay, so I want you to go ahead and press pause and try this one on your own. All right, so I'm assuming you press pause, and I'm going to go ahead and verify your answer. Okay, so 3 divided by 11, we're going to rewrite that as 3 divided by 11. Okay, so that 3, we're going to make that 3.0 and move our decimal right up. Okay, so 11 doesn't go into 3, so make that 0. 11 goes to 30 2 times. 11 times 2 is 22. 30 minus 22 is 8. So we're going to go ahead and add another decimal digit 0 and make that a little longer. 11 goes into 8 7 times. 11 times 7 is 77. 80 minus 77 is 3. We go ahead and we add another 0. 11 goes into 30 twice. 11 times 2 is 22. 30 minus 22 is 8. We go ahead and add another 0. 11 goes into 87 times. 11 times 7 is 77. 80 minus 77 is 3. We go ahead and add another 0. 11 goes into 30 twice. 11 times 2 is 22. And hopefully you're starting to see the pattern. 30 minus 22 is 8. We add another 0. 11 goes into 87 times. 11 times 7 is 77. And we're going to go ahead and stop there, because it's just going to keep repeating over and over and over and over and over for all time. All right, so what can we say about this one? We can say that 3/11 is approximately equal to, because it goes on forever, we can't say that this is the final answer, but we can say it approximately equals that. 0.272727, and it keeps on going forever. Or we can just say 3/11 approximately equals 0.27, and we put a bar over the 27 to show that 27 just repeats over and over and over and over again. All right, so that's how you convert a fraction to a decimal. All right, hopefully this video helped, and I will see you on the next video.